Okay, starting chapter 6, and we're live. It's a lot easier to grade because it's going to be more about finding a number answer. So I'm going to go through the text with you. I'd like you to turn to the text and follow along with me. I'm on page 302. Page 302. A point is equidistant from two figures when the point is the same distance from each figure. Perpendicular bisector theorem. In a plane, if a point lies on the perpendicular bisector of a segment, and that's what we have here. It's bisecting this segment because it's cutting it into two equal parts, and it's going through in a perpendicular angle, 90-degree angle. If a point lies on the perpendicular bisector, like point C, then it is equidistant from the endpoints of the segment. It's equal distance to the endpoints of the segment. So if you're on a perpendicular bisector, you're equal distance from each endpoint of that segment. Perpendicular bisector of a segment. Cuts it into two equal parts, equal distance to the endpoints. In a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector. Since D is equal distance from A to B, then it must lie on the perpendicular bisector. So this is the converse of this. But again, I don't care that you remember which one's the converse and which one. Just call it the perpendicular bisector theorem. ZX. These are problems I could give you on the Friday quiz. We won't have Thursday this week, but this section's a little short anyway, so it'll work. But we'll still have our Friday quiz, and it could come out of this monitoring progress. ZX is on the perpendicular bisector of WY and YZ. ZX is on the perpendicular bisector of this line segment, WY. YZ is 13.5. YZ is 13.5. Find WZ. How much would WZ be? This one right here is 13.5.
13.5.
Yes. Not hard, so if you get that one, you're going to gladly get that one right. Equal distance to the endpoints. Equidistant. ZX is a perpendicular of WY. ZX is a perpendicular of WY. WZ is 4n minus 13. WZ
You're 13.
is 4n minus 13. YZ is n plus 17. YZ is n plus 17. Find YZ. Find YZ. How would you do that?
N plus 17 equals 4n plus 13.
That's right. You'd set them equal to each other. Solve for n.
5n.
Okay.
Equals,
3n, right?
Yeah, 3n. Equals. I even knew that would do.
3n.
3.
Right? Yeah.
Yep.
So then plug n in. You got 10 and 17, so YZ must be 27. Okay, here's our other theorem. It's the angle bisector theorem. And it says if a point lies on the bisector of an angle, this point D lies on the bisector of this angle. That's cutting this angle into two equal parts, two congruent angles. Then it is equidistant from the two sides of the angle. And the converse is if a point is on the interior of the angle and is equidistant to the two sides of the angle, then it lies on the bisector. Now, this point D lies on the bisector of this angle right here. This angle is divided into two congruent angles. And the divider of that, the bisector of that, has point D on it. Point D is equal distance to the two sides of the angle. Now it has to hit those sides at a 90-degree angle. You can't say that these are equal distance. They might be the same length, but it doesn't tell you it's on the bisector unless those distances are perpendicular to the sides of the angle. Because the shortest route is the perpendicular bisector. Not bisector, but the perpendicular measurement. Line that's perpendicular to the sides of the angle. Now with that, we'll start doing some problems. Like in this case here, do you have enough information to conclude that QS bisects PQR? QS, here's S, bisects PQR. This angle right here is being bisected by QS. Do we have enough information? Well, it's equal distance to the sides. At least these blue lines are equal distance. However, they're not hitting at a perpendicular angle. So they could easily be the same length, but be a different distance from S to R and from S to P. Could be totally different distances. Could be the same length, but could be different, hitting at different angles. So in other words, if you've got a thing like this, you could have this angle here congruent to this angle here, this line here. However, they're not hitting at a perpendicular angle, then they're not the shortest distance. So we don't know that they're. So we don't have enough information because these are not hitting at a perpendicular angle. This one's a big one that I plan on giving you on Friday. Write an equation of a perpendicular bisector of a segment with endpoints -5, -1, -5, and 3, -1. Write the equation of a perpendicular bisector of that line segment. What do you think you're going to need? And by the way, you guys are live too, because this mic picks you up just as well as it picks me up. That would work. If you were going to do it by construction, a compass and a protractor would be a pretty easy way to do it. Sure would. I know just how to do it with that. However, I haven't done construction in this class because we just don't have time for everything. But you are going to, if you had a compass and a protractor, what would you find?
Whatever axis to make it your -5 and, or I guess your -1 and 3 and your -5, because you have two different coordinates, so.
Yeah.
You're going to have to find an angle which makes the two different.
Good.
It doesn't look like a straight line.
You're going to have to find the angle, that's right. What about the perpendicular line to this line? What happens to the angles, the slope? when you have a perpendicular line to another line? Remember what happens to the slope? First of all, let's find the slope of this one. -5 minus -1 over -1 minus 3. Yes.
Oh.
-5 minus 1, -1 minus 3. So I've got -5 plus 1 over -4. So I've got -4 over -4. So the slope of this line right here equals 1. What about the slope of the line that's perpendicular to that? Remember what happens? What happens when you multiply the two slopes? M1 times M2 equals -1. Remember that? So the slope of the perpendicular line must be -1 to be multiplied by this and get -1 for a result. Then it must be -1. 1 times -1 equals -1. So we know the slope of the perpendicular line. Now we needs to be a perpendicular bisector, meaning it has to cut this into two equal parts. So we have to find the midpoint. So what is the midpoint? Somebody help me write.
-1 plus 3 over 2.
Good.
And then -5 plus or I guess, yeah, whatever, over 2.
Good. You add the x's together, divide by 2. Add the y's together, divide by 2. So I've got 2 over 2. And here I've got -6 over 2. So I've got 1 and -3. So I found the midpoint. It's 1, -3. So now I've got the slope and a point. So I can use my point slope formula. Or I could use y equal mx plus b, go through and find b and rewrite it. Whichever you want to do. I'm going to use y minus y1, and y1 is -3 equals m, which is my slope, -1 times x minus x1, which is 1. So I've got y plus 3 equals -x plus 1, multiplying through. Y equals -x minus 2. Y equals -x minus 2. So that's the equation of the line. It's a perpendicular bisector of this line segment. It's this equation right here. So you're going to have a lot of those on Friday. So I like them because they come out to be a nice simple equation. Okay, let's start in with some problems in the text.
You want us to copy on paper or just listen?
Yeah, do them on paper. This is actually, I should have had you doing what we already did on paper. Now, you don't need to copy the problem. You got your book open. Just put number 3 and show all the work that I show. Find the indicated measure. Explain your reasoning. I won't make you explain your reasoning. They want to know G to H. G to H. What is this distance right here? Well, this must be a...
4.6.
Yes, because this is the perpendicular bisector, KH, is bisecting GJ into two equal parts because it's given to be the perpendicular bisector. Because let's see, this is 3.6 and that's 3.6. So yes, GH is 4.6. So that's all you have to write on that one. You get your book open so you can see the problems in there. QR, equal distance, must be a perpendicular bisector, so it must be bisecting QS, so QR must also be 1.3. These are easy, right? Maybe the hardest thing is finding the perpendicular bisector equation. And that's not very difficult either. AB. AB. Well, this must be the perpendicular bisector, this DB line.
5x equals 4x plus 3.
So we can set those equal to each other. That's right. So I've got x equals 3. So find the distance from A to B. AB would be 15 is correct. Notice you get 15 if you plug it in here too.
Same thing, 5x plus 4 equal to 7x plus 13.
Good. 9x plus 1 equals 7x plus 13. Yeah, I forgot to do attendance and lunch count.
So 7 times 6 is 36. 36 plus
7
13
times 6, 42.
42. What? 7 times 6 makes 22. Plus 13 is 55. So UW equals 7. Five, you have 5x equals 4x plus 3. Then you get x equals 30. Line AB equals 15. 5x equals to 4x plus 3.
How many of you are going to eat lunch today? I see 1, 2, 3, 4, 5. And me.
And then you get x equals 3. And then you get line AB equals 15.
Because it says it's right next to the number itself.
Okay, what'd you get?
5 for UW.
All right, 55.
Froze it.
No kidding, I did. Oh, I froze it. I threw it too. So 55. All right. Okay, measure of KJL. Oh, here we go. We're down here, right? Tell whether the information allows you to conclude that P lies on the perpendicular bisector of LM. Explain your reasoning. Okay, I want to know if P is on the perpendicular bisector of LM. Then all points that are on that perpendicular bisector are equal distance to the endpoints of that segment, LM. And they are equal distance from the endpoints. And it is perpendicular. So P, yes, is on the perpendicular bisector. Number 8. Does P lie on the perpendicular bisector of LM? Is P on the perpendicular bisector of LM? No, we don't know, do we? Because I don't know if it's bisecting, because I don't know if that's the same length as this. I don't know that. And I don't know that this is the same distance as this. All I know, it's hitting it perpendicular, so no, yes. I know you don't have much work to show yet until we get to those equations of a perpendicular bisector. Find the indicated measure, explain, perpendicular bisector of LM. How about this one? Is P on the perpendicular bisector of LM? Well, it's bisecting.
Bisecting.
Yes, it's bisecting.
So yes.
But
Equal lengths from MN and LN.
we don't know that this is equal length right here.
That's true.
And we don't know if it's hitting it at a perpendicular angle. Perpendicular bisectors have to hit at a perpendicular angle. So all we know is it's doing is it's dividing this, it's bisecting it. We don't know if it's perpendicular.
Next one's yes.
So that was a no. This one?
Yes, because your two sides are equal length to L and M.
Good. These are equal length. And because this is equal distance to the endpoints, then it must be hitting it at a perpendicular angle. It forces it to. That was the converse. Remember, the converse said if a point is equal distance to the endpoints, then it's a perpendicular bisector. Point P. So yes. Find the indicated measure. Explain your reasoning. Is this an angle bisector, DB? How do we know that?
Because the lengths between the 20 inches or whatever are the same. They're both 90 degrees and they show that they're the same from whatever.
That's right. These lengths right here are the same. And they're hitting at a 90-degree angle. So ABD must be 20. That's right. PS, again, it's a bisector of this angle, PQR. It's cutting it into two equal parts. These are perpendicular measurements to the sides of the angle, so PS must also be 12. If it wasn't cutting PQR into two congruent angles, then we couldn't say that this holds. But that must also be 12.
So PQS equals 12?
PS.
PS equals 12.
Yeah, PS is what we're looking for there. Equals 12. KJL. The measure of KJL. KJL. What are we going to do on that one? I want to know this measurement right there. Is that an angle bisector? JL, is that an angle bisector? Is JL bisecting angle KJM?
Yes.
Okay, yes, we know that because These angles are just, these measurements are the same length and they're hitting at a perpendicular
So
angle.
you have to put 7x is equal to 3x plus 13. So 4.
So K, J, L must equal 28 degrees.
KJL.
Yeah, that's what they're looking for, KJL. KJL. We found X is 4, so don't forget to plug it back in. X is not 4 degrees, it's just a number 4. But when we plug it in, we get degrees. FG. Find FG.
X plus 11 equals 3x plus 1.
Since X is 5, FG must be 16. 5 plus 11. Now we can get to some of those problems like I like working. No, they're down here. We still have a few more to go.
What was 14?
X equals 16.
Oops. Yeah. FG is equal to 16. Tell whether the information in the diagram allows you to conclude that EH bisects FEG. EH bisects FEG. Does the information that we have here tell me that it does bisect it?
Yes.
Yes. How about this one? Does EH bisect FEG?
No.
No, we don't know that. Tell whether the information in the diagram allows you to conclude that DB is equal to DC, distances.
Yes.
DB is congruent to DC.
Yes. Because it shows that it bisects angle A.
Okay, it does bisect angle A. However, these are not 90-degree angles. We don't know what angle they are, so we can't assume they're 90.
So no.
Right, no. I mean, if I exaggerate, one could be this and one could be this. And you can see those are two totally different lengths. So if they don't hit a 90-degree angle, we don't know how long they are.
18, yes, because you just said it.
Yes. Good, now we're down to some of these. I like these. All right. Without drawing it out. Yes. Without drawing it out. What am I going to need to find a perpendicular bisector number 9? Midpoint. Yeah, I'm going to need to know where the midpoint is because I'm going to bisect it. So I'm going to have
1 plus negative 2, or 8. Oh, sorry, I went the wrong one.
add
1
them
plus
together.
2, and then 5 plus negative 1. Over 2.
So I found the midpoint, 4, 2. Now I'm going to need the slope of the perpendicular bisector. So to do that, I'm going to need the slope of this line first, of this line segment. So I'm going to find the slope of it. So 5 minus negative 1 over 1 minus 7 is equal to 6 over negative 8 is equal to 3/4. Negative 3/4. Negative 1 minus 7, negative 8.
Is that a negative one?
Yeah, that's in there. I think it is.
Yeah.
No, it's a positive 1, isn't it?
Oh, it is. That line is just arrow above the 80.
1 minus 7. Yeah, that is a 1. Negative 6. So the slope again is negative 1. Well, that was easy. So the slope of our perpendicular bisector is what? No, negative 1's the slope of this line right here. So the perpendicular bisector is going to have a slope of 1. So instead of using a point...
equals 4 times 1.
Okay, instead of using a point slope on this one, I'm going to use y equal mx plus b, because you can do either way. Y
2 equals 1 times.
Okay, 2 equals 1 times
4.
4 plus b.
2 equals 4 plus b. B equals, so y equals x minus 2. 1x, so just x. I'll bet the next one will be a little more interesting. So you can use this, or you can use y minus y1 equals m times x minus x1. Which one do you like better, this method?
I like x plus b.
This one? Y equal mx plus b?
Yep.
That's one we're using. All right, number 20. Finding the midpoint. 0 or negative 2 plus 6, that's my x values. My y value is 0 plus 12 divided by 2. So I've got 4 divided by 2, and I've got 12 divided by 2. So I've got 2, 6.
Negative 2 over the...
No, it's just a mistake. You always divide by a positive 2. I just bumped it. So 2, 6 is my midpoint in number 20. Now I need the slope.
So
0.
6 equals 2x, or... Yeah.
I need slope though first. 0 minus 12 over negative 2 minus 6. Negative 12 over negative 8 equals positive 3/2. 4 goes in here, 4 goes in here. So the slope of this one right here is positive 3/2. So now I've got everything I need. I've got the midpoint, and I've got the slope.
So 6 equals 3/2.
Oh, hold on a second. 6 equals...
3/2.
Oh, no, 3/2 is the slope of this right here. I want the perpendicular bisector. So what's the perpendicular slope going to be? Because I have the slope of this. I need to be perpendicular to that. Again, when I multiply the slopes together, I get negative 1. So what am I going to multiply 3/2 times to get negative 1? Well, I could just ask it like this. 3 halves times x equals negative 1.
So 2. 3 halves times.
So x equals negative 2/3 to get negative 1. So my slope of it is going to be negative 2/3. Don't forget to find the perpendicular one. If you don't find the perpendicular one, you're going to find the same line that lies on. So, start me out again. Using this slope right here and this midpoint right here. Help me out. Y, which is
4.
6 equals m, which is negative 2/3 times x, which is 2, plus b. 6 equals negative 4/3 plus b. This is 1 1/3, so this is 7 1/3. I'm adding it to both sides.
Still 20.
Number 20. So b is 7 1/3. So again, y equals negative 2/3 x plus 7 1/3. So it takes a little bit of work, but it's not hard. The only two things you need is the midpoint, which is simple, and the slope. And then plug it into y equal mx plus b. Be sure you find the perpendicular slope though, which is always a negative reciprocal of that slope. Okay, I'm going to go through these next two kind of fast, so just write them down as I go. First, I'm going to find the midpoint. I've got 4, oops, I've got negative 3 plus 9 over 2, and 4 plus 8 over 2. I've got 6 over 2 and 12 over 2. I've got 3, 6. Nice midpoint, nice even midpoint. So now I need to find the slope of this. I'm on number 21. So I got 4 minus 8 over negative 3 minus 9. I've got negative 4 over negative 12 equals 1/3. So the slope of this thing right here is 1/3. So the slope I'm going to use this point, and what slope am I going to use?
Y.
Here's what slope I have. I want the negative reciprocal of it.
Negative 3, 1.
Good. Negative 3, so I'll just put it down like that. So now I'm ready to write my equation using y equals mx plus b. I have y as 6 equals negative 3 times x, which is 3, plus b. So 6 equals negative 9 plus b. So b equals 15. Since b is 15, I can write my equation y equals negative 3x plus 15. These are the only ones that take any work at all. And again, it's real simple as long as you just think about it, don't make a mistake, which is what I'm trying to make sure I don't do. So far, I think they're coming out clean. Okay, we got time for the last one, then we'll be done for today. 22, I'm going to find the midpoint again. I've got 10 plus negative 4 over 2. I've got negative 7 plus 1 over 2. I've got 6 over 2. I've got negative 6 over 2. So the midpoint is 3, negative 3. So that's the midpoint. Now I'm going to find the slope of number 22. Slope is negative 7 minus 1 over 10 minus negative 4, which is negative 8 over 14, which is negative 4 sevenths. Negative 4 sevenths. So the slope of this thing right here is negative 4 sevenths. So what slope do I want? Negative 4 sevenths times what is negative 1? Well, you can write it out and find it, but it's just easy to think about negative reciprocal. 7/4, that's right. Change the sign and flip it over. So you're going to use 7/4. So that's going to be your slope. So I'm going to use, I'll use y max supposed to be. Negative 3 equals 7/4 times x, which is 3, plus b. Negative 3 equals 21 over 4 plus b. 21 over 4 is equal to 5 and 1/4 plus b. So this is negative 8 and 1/4 equals b. So y equals m, which we found to be 7/4 x minus 8 and 1/4.
Hey, doggies.
Why don't you hold on to them until tomorrow? That way you can go over to work at home or at...